afternoon, everyone, and welcome to the first National Weather Service Partners webinar for the 2022 Spring Hydrologic Outlook. I am Katie Ertel, a hydrologist at the National Water Center, and I will start the presentation today by giving a general overview of the Spring Hydrologic Outlook for the Greater Mississippi, Souris River, Red River of the North, and Great Lakes Basins. Today, we will also hear from representatives from each of the 5 river forecast centers for more detailed information on the flood potential for their respective regions. This webinar is being recorded, and a follow-up email will be sent with information on how to access that recording. If you have any questions during the presentation, please go ahead and type it into the question box on this GoToWebinar GUI, and we will address it at the conclusion of the presentation. All right, so let's jump right in. We're going to start today by taking a look at the winter precipitation so far across the Greater Mississippi Basin and how that compares to last year. A couple of differences can be seen this year as shown in that center graphic and last year shown in the graphic on the right. The most noticeable of those is across the northern plains and in the mid-Mississippi Valley through the Ohio Valley, where you can see those blue and green colors. These regions have seen above normal precipitation, even 200% plus of mean in some locations for this 2022 winter season so far, so very different from last year. However, overall, below normal precipitation this year for the season can be seen across the remainder of the Greater Mississippi Basin. If we shift our focus to the graphic on the left there, you can see that additional precipitation over the last 2 weeks, as indicated again by those green and blue colors, did help contribute to that trend across the Midwest and Ohio Valley. However, also of note, we did continue to see a dry period across the Central Plains and into the Northern Plains as well over the last 2 weeks, so further deepening the precipitation deficit over those regions. If we move on to the next slide in the graphic on the left, again, looking just at the last 2 weeks, you can see that most of the basin has seen cooler than average temperatures with the exception of the upper Missouri Basin. Those colder temperatures recently across the Northern Plains, Midwest, and even into the Ohio Valley this year do continue to heighten the concern for ice development, which the RFCs will cover later on in the presentation. Seasonally, there is quite a big difference from last year, especially in the Northern Plains, where temperatures are colder this year, as you can see comparing that center graphic to the graphic on the right. Overall, though, across the remainder of the basin, temperatures are still above normal and warmer than 2021, so ranging from 2 to 6 degrees departure of mean, especially in the lower Mississippi and Tennessee River valleys. Now let's take a look at the snow water equivalent that we're holding onto across the basin heading into the spring, so just how much water is being held in the current snowpack. With the current year on the left, the first thing you'll notice across the Mississippi Basin is that we have more snow water equivalent in the upper Midwest and into the Great Lakes compared to last year. So Mike from North Central River Forecast Center will go more in depth on what this means for flooding in that region this year. However, alternatively, across the upper Missouri Basin, there's a noticeable lack of snow this year. So we'll hear from Kevin at Missouri Basin River Forecast Center about the implications of this in just a few minutes as well. There have been a couple of snow events over the last 2 weeks that have increased the snow water equivalent across the Midwest and into the Ohio Valley. And as we'll see a little later in the presentation, there is more snow and rain potentially on the way beginning day 7 across those regions. Now taking a look at the soil moisture across the basin, compared to last year, the soil moisture content is elevated across the Ohio and Tennessee valleys, which does coincide with those areas of above average precipitation that we saw earlier in the slide. Compared to last year, across portions of the eastern Dakotas and western Minnesota, there were a couple of rounds of late season precipitation before the winter freeze, so that locked in more saturated soils across that region. Different story, however, across the upper Missouri. This area saw a prolonged dry period leading into the winter, and as mentioned earlier, has received very little snow this season to alleviate that. Also of note, we're seeing some isolated pockets of lower soil moisture content in the upper Midwest and the Arkansas Red and lower Mississippi River valleys as well. Now looking at the current U.S. Drought Monitor, this was just released this morning. So after seeing all the information on the previous slides, Not very surprising that we have very little drought across the mid-Mississippi and Ohio Valley. However, a very different story further west, with widespread dry conditions and even areas of extreme drought over portions of the upper Missouri, Arkansas Red Basin, and portions of the lower Mississippi as well. Taking a look at the USGS 7-day stream flows, most of the Mississippi Basin is experiencing normal to slightly above normal stream flow, as you can see in those green and blue shades on the map. This is a bit of a change from last year, as you can see in the graphic on the bottom right, where there were some portions of the basin that were drier, particularly in the Ohio Valley. You will notice those white sections in the upper Midwest and the northern plains as well. That's where we're currently iced in, or where seasonal gauges are not taking measurements. But there are some greens and blues peeking out there, indicating that where there is flow, it's normal to above normal right now. Moving on to this slide, we wanted to highlight this because elevated water levels can have an impact on flooding of inland streams and rivers. This information comes from the U.S. Army Corps of Engineers Detroit District, and this is based off of the February 6-month forecast, which forecasts for the months of February through July. So besides Lake Superior, all lakes are currently above their long-term average levels, but they are forecast to remain well below those record high levels this spring and early summer. Now switching gears a little bit, we're going to look at the temperature and precipitation forecast and the weather and climate outlooks that are going to influence our hydrologic river outlooks into the spring. So a couple of systems are expected over the greater Mississippi Basin in the next coming week, the next 7 days, which will cause temperatures to fluctuate, but we are expecting very little precipitation at least days 1 through 6. So all of the precipitation that you see on this graphic here is day 7, when we are expecting widespread precipitation, both snow and rain across the central U.S. If we move on to the week 2 outlook from the Climate Prediction Center, there is an increased probability of above normal temperatures over the central portions of the United States and an increased probability of near normal temperatures just across the upper Midwest and Great Lakes. For precipitation in week 2, the majority of the greater basin is leaning towards normal probabilities of precipitation, and with the exception of portions of the northern plains, which are leaning towards normal or even below normal probabilities for precipitation in that week 2 period. Looking further out at the latest seasonal outlooks that are going to take us through April, as is typically expected, the probabilities favor above normal temperatures across the majority of the United States. As is common in a La Nina pattern, probabilities also show that above normal precipitation chances are gradually going to shift to the north into the Ohio Valley and Great Lakes region. This will be extremely important to watch, as flooding susceptibility in many of these locations across the greater Mississippi Basin are driven by those convective rainstorms, which are typical in the springtime. And as we saw on the previous slides, the Ohio Basin going into the season is already above average in terms of precipitation and soil saturation. With that, I'm now going to pass it over to Jim Knoll from the Ohio River Basin to go into more depth on the potential of spring flooding across that region.
All right, thank you, Katie. And yeah, things are kind of going here in the Ohio Basin. We've already had several minor flood events in December, January, and February. And it looks like it's going to get much more active here very soon, as Katie said. If we move on to the next slide. The slide will be showing that we're taking a look here at 2 images. On the left side is the temperature of the snow and ice pack. That red area in Indiana and southern Ohio is where it's about ready to release. We expect some of that to release here tomorrow. But you can see further north where you see the blues in northern Indiana, northern Ohio, and western Pennsylvania, that snowpack temperature is still very cold. So we don't think that'll be releasing, until next week's storm system. But a lot of that now does appear to be going to be released later next week. So please continue to monitor later forecasts. The right image shows snow depth relative to normal, and the big 2 things that stick out is above normal snowpack north of the Ohio River and below normal snowpack because of the storm about a week ago over West Virginia. So basically, we're kind of a tale of two Ohio valleys right now in terms of the snowpack. Above normal to the north of the Ohio River, and generally below normal to below normal to the south. Again, we do expect most of this snowpack now, except for northeast Ohio, northwestern Pennsylvania, and southwest New York, will be released. Most of that will be released late next week. In addition, we do, on the next slide, we do have ice jam action, mainly north of Interstate 70, and particularly north of Highway 30 in Indiana and Ohio, and then extending also into northwestern Pennsylvania. And we do expect some issues with that, with the storm coming up late next week. So that will add complexity to a rain event that right now looks to be a 1 to 3 inch rain event across portions of the Ohio Valley. As Katie said on what she was talking about on day 6, 7, and one more day on day 8. So like later next week and in early next weekend does look somewhat problematic across the Ohio Valley, as we are fully in our flood season right now. This is the most ice that I can recall really since the winter of 2013 and 14 in a widespread nature across the northern Ohio Valley. So one other thing to note, our official outlooks do not include ice jam action. That's a very complicated thing. And so that's handled kind of on a case-by-case basis as an event unfolds. So moving on to the next slide, right now it looks like we are talking about a fairly widespread minor to moderate flooding season, really from February through March and April across a good portion of the Ohio Valley. You see a lot of orange and red dots there. Those are actually at the 50% chance. It takes a lot to get 50% probability in the Ohio Valley because rainfall tends to be the biggest driver. So on the next slide, we really try to look at the 25% chance, or what is possible. And this paints a picture of, you know, what a lot more of what we can really expect here in the Ohio Valley. That is, there's a fairly decent risk of getting a minor to moderate flood event, and even some scattered major floods are possible, depending on how each one of these individual weather systems comes out over the next couple of months. If we move on to the next slide and we kind of break it into those two sections I talked about, the northern Ohio Valley and the southern Ohio Valley, really we're going to be touching most of our basins. I'm going to start north of the Ohio River here for eastern Illinois and Indiana. We are expecting the basins of the Maumee, the White, the East Fork of the White, the Wabash, the Patoka, and the Embarrass, all to receive minor to moderate flooding. And I did highlight the Little Wabash and the Skillet Fork in southeastern Illinois. We do expect minor to moderate flooding, but I colored them purple because major flooding is possible in those areas of southeastern Illinois. Further to the east in the northern Ohio Valley, north of the Ohio River, for Ohio and western Pennsylvania, southwest New York, we do expect fairly widespread minor to moderate flooding in the Maumee, the Great Miami, the Scioto, the Muskingum, the Beaver, and all the Lake Erie drainage, all the rivers draining into Lake Erie, as well as really the upper Allegheny in southwestern New York and northwestern Pennsylvania. And then again, I colored in purple that the Stillwater Creek, we're expecting minor to moderate flooding, but there's at least a 25% probability of seeing major flooding there in portion of the Muskingum Basin. So we have to watch this. And it all depends on how the rainfall combines with the ice jams and the ice movement, as well as the snow water equivalent within the snowpack coming out. Moving on to the next slide, further south of the Ohio River, it's a little bit more in terms of the 50% chance of getting flooding. We're expecting more in the minor to a few moderate floods. But again, if you look at those 25% probabilities I showed earlier, there's a 25 to 50% chance of really minor to moderate flooding across a good portion of Kentucky, even into portions of northern West Virginia, and even down into portions of middle Tennessee. But for the most part, we are right now forecasting with at least a 50% chance that the Green River, along with the Kentucky, Licking, and Cumberland basins in the state of Kentucky, which are the big watersheds, all should experience at least minor flooding and possibly moderate flooding. And then also the Monongahela River in northern West Virginia. Along the main stem of the Ohio, we do expect minor flooding, at least minor flooding below Louisville, But again, looking below that, there's a lot of those probabilities which we have to respect in the 25 to 50% range, saying that there is the possibility of minor to moderate flooding along really the entire main stem of the Ohio River from about a week from now all the way out to early April. After that, things probably peak and start to calm down as we go forward. And finally, moving on to the next slide. In summary, again, minor to moderate flooding is expected this spring across a good portion of the Ohio Valley, and major flooding is possible. Our conditions are wet, and they are definitely wetter than last year. And typically in a normal year, we don't see much more than minor flooding on a 1 to 2 year kind of typical basis. This year, we're expecting at least minor to moderate flooding. So we do classify most of the Ohio River Basin as above normal flood risk. In a few weeks from now, we'll be able to fine tune that a little more. But again, we do expect the flood risk this year is above 2021, but not as high as years like 2011. There is ice jam risk north of Interstate 70 over the next 1 to 2 weeks. And again, we do expect a lot of our snowpack now to come out in about a week from now, except for Northeast Ohio, Northwest Pennsylvania, and Southwestern New York, and that will contribute to flooding as well. After the next couple of weeks, then we're going to get into our more typical, where it's going to be the storm systems and the rainfall that will drive future additional flooding. And with that, I'm going to go ahead and turn it over to Mike at the North Central River Forecast Center.
Thank you, Jim. And also thanks to Katie for setting us up with all the weather parameters leading into this. So for the northern part of the country here in our service area, I'm going to start out looking at soil moisture conditions. So last summer, you may recall that much of our service area was in the grip of a severe to extreme drought. Parts of North Dakota and northern Minnesota were even classified as a D4 exceptional drought. But those areas did get some timely rainfall during the fall period, and that helped to increase the soil moisture levels up in that vicinity. So those are the areas you see here in this map that indicate white or maybe just a light yellow shading in the upper Midwest. Those areas were in drought, but now it looks like the soil moisture has recovered. There are still some dry areas across our service area, especially over the Dakotas, parts of Minnesota and into Wisconsin, parts of Iowa as well. But overall, the soil moisture is much closer to a normal state than it was 6 to 8 months ago when we were looking at this. On the next slide, we'll compare this. Note that the drought class designation change here on this chart that has occurred since August of last year. So between August and the end of January, precipitation in Minnesota and Iowa really helped to improve the drought conditions. And in fact, the drought designation was removed altogether in some portions of those areas, as you saw on that last slide, the white areas we talked about. However, note that in Wisconsin, the precipitation didn't quite seem to make it there, and the drought has actually worsened across Wisconsin. And you can see that in the yellow and orange shaded areas, which indicate a 1 or even 2 or even 3 class degradation in drought, so much drier across Wisconsin. Looking forward, let's take a peek at what we've got for snow water. Katie showed a slide similar to this early on, but I want to zoom in on our area a little bit. The moisture has kept on coming through the winter, especially across the north part of our area. Snowfall has been well above normal across North Dakota and into Minnesota and stretching over toward Lake Superior. Snow water content as of just a couple of days ago here was running from 2 to 3 inches up to as much as 4 to 5 inches of water content in the snow across parts of North Dakota and Minnesota. Some higher amounts up to 6 inches or even more were found in parts of the Minnesota Arrowhead region and stretching over into the Upper Peninsula of Michigan. That's kind of typical for those areas, so it's good to see that they've got more snow on the ground after a couple of dry years. One other area of enhanced snow water content that you can see was a result of the storm that affected parts of Missouri up through Illinois and northern Indiana last week. You can see here that there's about an inch of water in that band, but as Jim mentioned, the snow temperatures were warming and a lot of that was melting and releasing already. So we do expect much of that snow to be gone as we move through the next few days here. So how does this snow rank in our modeling system when we take a look at historical? So we're looking at it here, and this is a map that was produced out of our modeling system, and it's ranking according to the historical average that we've seen. So historical and how we compare to that. So there's three distinct areas that you can see on this map that stand out. First of all, the warmer orange and red colors, that indicates a low amount of snow water in the lowest 20% of all years of our comparison history. So much less than normal amounts of water content. So that area in Wisconsin that we noted is still in a drought, and note that the snow rank there is at best it's normal, but mostly it's trending below normal in Wisconsin. The other two areas that I'm talking about are the darker shades of blue that you see, and that indicates snow water content in the highest 70 or 80 or even 90% of all years in our rankings. These areas are higher than normal for this time of year of early February for the amount of water that's contained in the snow on the landscape. So up in the Red River Valley in North Dakota and western Minnesota, especially on the North Dakota side, the amount of water content in the snow is ranked in the top 10% in our historical record. So that area really has our attention this year as having a risk for some snowmelt runoff flooding. Further south, you can also see that blue well to the south from Missouri into Illinois, and that's a result from that snow band we talked about. So the ranking there is in the top 10 to 20%. However, when we look on the next slide, this is going to show the actual water content in the snow that goes along with that ranking we just saw. So the higher rank down there is more of an indicator that that area typically doesn't have a snow cover at this time of year. So the actual amount of water in the snowpack is less than an inch down there, and as I said, it's going away soon. So much of that will be gone, and it shouldn't impact things. But the northern snowpack, that has a lot more water in it here. You can see in the green shades from 2 inches up to 4 inches. So our attention again is focused up here in the Red River Valley of the north. So let's take a look next at our overall flood outlook for the North Central River Forecast Center area. Not surprisingly, all the things we've looked at so far are borne out in our flood risk potential. Much of our area is showing about an average risk for flooding, with the exception of that Red River Valley area, and also maybe parts of the lower Souris River up in north central North Dakota. In those areas where the flooding has a greater than 50% chance of occurring, it appears that the most likely outcome is going to be of the minor flood variety. Perhaps some could reach the moderate level. Of the over 450 forecast sites that we have in the North Central RFC area, there's only 89 that are showing a greater than 50-50 chance for reaching that flood stage level this year. And only a very small number of those, about 20, are having a greater than 50% chance of reaching moderate or even major flood stage. And that's denoted by the reds and purples that you see in the Red River Valley there. So let's zoom in on the Red River Valley here in the next slide. Our primary area of concern this year seems to be up there where that heaviest snow and the amount of snow water is lying. Generally, that is the eastern part of North Dakota and parts of western Minnesota. Most of that flooding is expected to remain in the minor category, as I said, perhaps reaching moderate. And if things go wrong or right, depending on how you look at it, we could see some spots reaching the low end of the moderate category, or the major category, I'm sorry. So this above average flood risk in the lower Souris River that you see up there in north central North Dakota, that's a little bit conditional up there. So the upper part of the Souris is well within a drought, and many of the reservoirs that are up in Canada that feed into the Souris River there don't have a lot of water in them, and they're not going to be releasing any additional water. So the upper portion of the Souris from Minot and upstream, we're not looking at much of a risk of flooding there at all. But downstream, they had more snow and there's more rainfall in the fall. So there is a chance that the lower part of the Souris could reach minor flood stage, but it'll depend on how the melt takes place. So other things that go into the potential for flooding would be frost depth, and we'll look at that on the next slide. Frost depth can enhance or reduce the severity of flooding each spring. It's the depth of the frost that penetrates into the ground. So cold temperatures that we had from late December through January and into the early part of February allowed the frost to go rather deep in places. And as you can see on this graphic, the darker shades of blue indicate the deeper frost. Some areas have frost down to 2 or 3 feet, and the lighter shades are indicating a more shallow frost depth of about 12 inches or even less. And frozen ground, it can act as a barrier like concrete so that when the snow is melting, it can't really soak into the ground, and it would have to run off directly into creeks and rivers. In areas with less frost, the ground can thaw faster, allowing more of the melting water to soak in. So for areas with the deep frost, we're going to have to watch out for rapid melting scenarios or any precipitation on top of a frozen ground, which can cause an enhanced risk of flooding there. One other factor that we look at is ice jams, and Jim touched on this a little bit in his area. The deep cold that we had through January and into early February really created a lot of ice further south than we normally see it. We do get a lot of ice jam issues in our area every winter, but it looks like this year we had more ice that reached even further south. So some of this has caused some difficulty for shipping along the Illinois River and also down in parts of the Mississippi River as well. Otherwise, so far, true ice jamming hasn't really been much of a problem in our area so far this winter. We do get some every year, and we've had a few minor ones, but nothing real substantial so far. But we are watching out for that possibility later this spring. So when the river levels do start to rise, they can break up that ice into large chunks that go downstream, and sometimes those chunks can get hung up on bridges, sharp bends in the river, or other obstructions, and that can cause some jamming. So we're going to have to watch out for that possibility as temperatures warm up here in the coming weeks. So in summary, I'm going to finish up here on this last slide. Our overall risk this spring is generally about average for the majority of our region, the exception being the Red River Valley, as we talked about, where that risk is above normal this year. The indication is that in areas where we do see flooding, most of it should remain minor. And we do have a risk for some ice jamming here and there, but it also seems to be a bit lower than in most years. And as usual, spring precipitation and temperature patterns in the coming weeks here are going to determine just how our snowmelt rate and runoff timing happens and what our eventual flood risk will be. So that's it for my area. I'm going to now pass it on to Kevin Lau at the Missouri Basin River Center.
Thank you, Mike, and good afternoon, everyone. There is an overall reduced risk for flooding across the Missouri River Basin this spring. And to illustrate, I would direct you to the graphic on the left-hand side of this slide. The 400 plus forecast locations within the Missouri River Basin are depicted as colored dots in this graphic, and the color of the dot indicates the percent difference of flood risk this year for a given location as compared to the past 30 years. Blue dots indicate a reduction in flood risk, and red dots indicate an enhanced risk for flooding. And to aid in visualization, because I know those dots are pretty small, we've also shaded in larger areas where chances predominate in one direction or the other. So as you can see, there are large areas of the Missouri Basin where flood risk is reduced from historic normals by anywhere from 10 to as much as 30%. That's the blue shaded areas sprinkled across the basin. There is an enhanced risk for flooding in extreme eastern Dakotas, and I'll address that later on in my presentation. Now, a word of caution: reduction or enhancement of flood risk does not necessarily mean that we expect a particular location to flood or not to flood. Decreased or increased flood risk simply tells us what direction we're heading. And in later slides, I will actually pinpoint those basins where flooding is expected. So for right now, I just want to impress upon you the fact that flood risk across the Missouri Basin is reduced from normal. So going to the next slide, we'll look at the mountains. The mountain runoff is important for the Missouri Basin, as mountain runoff contributes about 35 to 40% of the annual runoff of the Missouri Basin. This graphic, courtesy of the Natural Resources Conservation Service, or the NRCS, shows the mountainous basin snowpack conditions in percent of average snow water equivalent. That's the amount of liquid that's in the snowpack. Mountain snowpack can be categorized as being below normal over all but the Platte River system. Both the North and South Platte headwaters have a near normal or near average snowpack. By this point in the winter, we've normally accumulated about 65% of the seasonal peak snow water equivalent in the mountains, and so we still have a little ways to go, and things could change. Moving to the next slide, this next slide attempts to graphically summarize what that snowpack results in. It gives the most recent water supply forecast that was issued on February the 2nd by the Missouri Basin River Forecast Center. It suggests that we have a much below average mountain runoff year this year, volumetrically speaking, for all of the mountainous west, with the exception again of the North Platte Basin. The North Platte is poised to have a better than average runoff year. Significant flooding from mountain snowmelt alone is not expected in 2022. With our next slide, that is courtesy of the Office of Water Prediction, we see that the only plains snowpack that we have within the Missouri River Basin is in the eastern half of North Dakota and a little bit in the extreme northeastern portion of South Dakota. 3-inch snow water equivalent is being reported or estimated in that area up there. So now I will go area by area through the Missouri watershed, highlighting those basins where our long-range outlooks indicate a better than 50% chance of seeing some sort of flooding. Starting here with North Dakota, we do expect moderate level flooding along the James River. Moving southward into South Dakota, major level flooding is likely downstream of the reservoirs to the vicinity of Ashton, there along the James River. Downstream of Ashton, minor flooding is expected along the James. Also, the upper reach of the Big Sioux is also favored to see minor flooding. Going even further southward into eastern Kansas and the state of Missouri, minor to moderate flooding is expected along many of the tributaries in extreme eastern Kansas and across the state of Missouri. And this is nothing new. Thunderstorm activity drives springtime flooding in this area of the Missouri River Basin, but I will hasten to add that we have not seen any flooding in this area since before Thanksgiving. The absence of flooding for the past 2.5 months in the lower basin is impressive. And although it's not specifically shown on this graphic, minor flooding is possible at 1 or 2 locations along the Missouri River itself, downstream of Kansas City over the next 90 days. However, flood chances increase for the Missouri River downstream of Gavin's Point Dam long about late May into early July. Although not technically a spring flood outlook, I will say that we do expect episodic on-again, off-again minor flooding along the main stem Missouri River in the reach extending from Nebraska City down to the mouth later on this year. So, in summary, for the Missouri River Basin, spring flood risk is lower than normal. Mountain snowpack is below average so far. We've still got roughly 35% of the accumulating season left, so things could change. Flooding due to mountain snowmelt alone is not expected. Plain snowpack is pretty much non-existent, the exception being the eastern North Dakota and a little dab of northeastern South Dakota. Water year 2021, which extended from October of 2020 through September of 2021, was the 17th driest year on record for the Missouri River Basin. And as a result, the most recent Drought Monitor categorizes 87% of the Missouri Basin as abnormally dry or worse. The months of December and January were the 21st warmest December, January on record. So dry and warm is the overarching story within the basin. And so that leads us to a couple of assumptions. First, we don't believe that frozen ground is going to aggravate runoff production in the plains this year. Soils are cold across the northern tier of the basin, but we suspect that the ground is still capable of absorbing some of the snow melt, the rain on snow, or rain events that we will get through the spring. Now, a possible exception to that would be in the Dakotas, where precipitation in October, December, and January benefited the soil moisture, especially in the eastern portion of North Dakota and the extreme northeastern corner of South Dakota. It is possible that the available soil moisture at that time and the cold temperatures have produced a frozen ground condition in that area. This, along with the presence of the plain snow, helps to explain the risk for flooding that we're now seeing along the James and the Big Sioux. Dry and mild conditions also lead us to a second assumption, and that is that we believe that we have an overall lower than normal ice jam breakup flood risk this year. It's not to say that ice jam flood risk is not existent. Elevated stages have already been seen due to river ice action along the Middle Loop and the North Platte rivers in Nebraska, Jefferson and Gallatin in Montana, and the Wind in Wyoming. Impacts thus far, though, have been minor and localized. While ice jam-induced flooding will remain possible in the northern and western regions of the Missouri River for the next few weeks, this week's warm-up that we're experiencing in the southern portion of the basin probably will lead to the river ice out for the season in the lower part, or in Nebraska southward. Thunderstorm activity typically drives flooding in the lower basin, and so we are expecting episodic minor to moderate flooding this spring across southeastern Nebraska, eastern Kansas, a little bit of southern Iowa, and across the state of Missouri. And for the Missouri River itself, the best chances for flooding will be in late May through early July. Again, on again, off again flooding is likely from Nebraska City to the mouth, but that's later on than the spring. Okay, well, thank you, and this concludes the flood potential brief for the Missouri Basin. I'm going to turn the presentation over to Lee in the Arkansas Red.
Thanks, Kevin, and good afternoon, everyone. I'm going to jump right in by going over the Arkansas Red Basin's current conditions. On the next slide here, starting in Colorado, this plot shows the snow water equivalent of the subbasins within the Arkansas Red Basin there in Colorado. As of this morning, the entire Arkansas Red Basin was at 87% of normal snowpack, or snow water equivalent. If you remember from the Drought Monitor map earlier, much of Colorado is in significant drought, but the good news is that there's still almost 2.5 months to continue building up that snowpack. On the next slide, on the left, I have our liquid precipitation estimates over the past 90 days with respect to normal across our basin. As you can see, it's been pretty dry, continuing a trend from the fall of 2021. Most of the basin saw less than 75% of normal precipitation, and a large area has seen less than 25% during that same time. On the right is the latest Drought Monitor updated this morning. It's focused on the Arkansas Red Basin. Much of our basin is experiencing significant drought. The next slide shows the status of the Corps of Engineers and Bureau of Reclamation reservoirs, showing the amount of flood storage available. All of these reservoirs are in really good shape, with most lakes having their entire flood pool available. Within the Corps' Tulsa District, the Arkansas River System and the Red River System are each using about 1% of their total flood storage. On the next slide, we have the long-range forecast of rivers having a 50% or greater chance of flooding in our area. Although we aren't seeing any widespread areas of above 50% chance of flooding, we do have a few rivers which we're more concerned about in the eastern part of our basin. These include the Neosho River in northeast Oklahoma and the Illinois and Poteau rivers in eastern Oklahoma. It should be noted that these rivers are the usual ones that have a higher chance of flooding in any given year, so this is not out of the ordinary. So in summary, despite our current dry conditions experienced across the basin, we are calling for a near normal flood potential across the Arkansas Red Basin. As a reminder, most spring flooding that occurs within the Arkansas Red Basin is driven by convective storms, which can occur over any part of our watershed. And with that, I'm going to pass it off to Jeff Groschel at the Lower Mississippi River Forecast Center.
Thank you, Lee. Good afternoon. We'll talk about the lower part of the river now, and actually it's been pretty dry across our area for the most part. The exception would be over in the Tennessee Valley, where we've had several periods of rainfall and several events and caused some minor flooding over portions of that area. And Katie, earlier in the briefing and stuff, indicated the soil moisture conditions being above normal over that area. But for the rest of the area, though, it's been very dry. Actually, drought conditions over in portions of Louisiana. Currently, right now, we typically have a lot more minor flooding, even some moderate flooding across our area this time of year. But we really have only seen now just some minor flooding along the coastal sections of Louisiana and Mississippi. Going to the next slide, talking about the Mississippi and the Atchafalaya rivers. What we're seeing right now is probably just some average conditions across the lower part of the Mississippi River. We've had several events on the lower part of the Ohio River. We had a little bit of minor flooding that occurred in the early portions of January, but because we really didn't have a lot of contribution from the Missouri or the Mississippi, we really didn't see much on the lower part of the Mississippi River. The other thing to note too is we have very dry conditions along the Red and the Ouachita basins too, so in Louisiana. So right now we're really just not anticipating as much, and maybe just some average conditions right now for the lower Mississippi and the Atchafalaya River, and we're really only anticipating just some minor flooding right now. And we'll go to the next slide. For the Tennessee and northern Alabama area, like I mentioned before, soil moisture conditions are a little bit more above average for this area because of the rainfall that we've had over the last several weeks. So probably we are looking at some minor to maybe some isolated moderate flooding over portions of this area for the tributaries going into the Tennessee River. On the next slide. For Arkansas and Missouri, again, really not anticipating much more than just some minor flooding across this area here for southern parts of Missouri and for the areas of Arkansas, mainly some of the tributaries into the Black River and on the lower part of the White River. Next slide. For Louisiana and Mississippi, for the state of Mississippi, we're looking at maybe just some minor flooding for portions of like the Yazoo, the Pearl River, Pascagoula River systems. But as you go further westward into Louisiana, really only anticipating maybe just some minor flooding, maybe in the Calcasieu. The Red and the Ouachita, again, as we mentioned before, kind of into severe drought right now. So we're really not anticipating much in the way of flooding, and hopefully we will get a little bit of rain during the winter and springtime to actually help some of the drought conditions that we have across that area. So minor flooding, maybe some isolated moderate flooding in portions of this area if we get some heavier rain, but primarily the threat's not quite as much as what we typically have for this time of year. And going to the next slide. In summary, really the only area that you might consider to be above normal might be the middle portions of the Tennessee Valley, near normal for the rest of the area, and actually some below normal areas and portions of Louisiana. Only anticipating minor flooding for the lower Mississippi, lower Ohio, and Atchafalaya rivers that are in our area. Minor flooding with some isolated moderate flooding is possible over portions of the lower Mississippi Valley. Just like everybody has said though already, snow melt really isn't a problem for us. It's the rainfall that really gives us any sort of the flood threat for the lower parts of the Mississippi River. So the frequency, intensity, and extent of the rainfall will really determine that final outcome of the flood risk for our area. And with that, I will pass it back over to Katie at the National Water Center.
All right, thank you so much, Jeff, everyone. I'm gonna sum everything up, or try to real quick. So the flood risk is considered above normal for much of the Ohio Valley. It is normal to above normal for portions of the James and Red River of the North, and as Jeff just mentioned, also potentially the Tennessee Valley this season. A significant flooding due to just mountain snow runoff is not likely due to that normal snowpack we saw there. And again, as you've heard through the whole presentation, ultimately the amount of snowmelt, frequency, intensity, and the extent of the rainfall throughout the season is going to determine the final outcome of the flood risk. We are going to enter into a question and answer session right now. So if you have any questions for today's presenters, please utilize that question box in the GoToWebinar GUI, and we will ask those questions to our RFC members. We'll stay on and give you guys a couple more minutes to get those questions in, but as always, thank you for your participation in today's webinar. This recording will be distributed via email along with an invite to the next Greater Mississippi Partners webinar, which will be on Thursday, February 24th at the same time, so 2:30 p.m. Central Time. Well, remember, if you ever have any questions after this, please do not hesitate to reach out to your respective River Forecast Center for further assistance. All right, we are not seeing any questions at this time. So thank you everyone again and have a great afternoon.